Hello and welcome everyone to this new Dataiku webinar dedicated to the supply chain and how this strategic function for many companies can be augmented by AI. I'm welcoming today Igor Girard-Carrabin, who is managing the SESAME project at ArianeGroup,
Good
and
afternoon.
Damez, good morning or good afternoon, and Marc Damez-Fontaine, who is Director of AI and Data at PwC. On my side, I'm Pierre Carrère, responsible for partnerships at Dataiku France. During this session, I invite you to ask us all your questions in the chat section. Our guests will answer them at the end of the session. You will also be able to download the presentation, which will be made available on the BrightTalk platform. So, Marc, let's start with you. Marc, you recently participated in the writing of our supply chain white paper on AI for supply chain. Can you please summarize your thoughts on this?
Yes, sure. Thank you, Pierre. So I tried to resume our value proposition for AI in supply chain without entering into technical details or algorithms. So just to give the audience the ability to understand what are the different levels of involvement of AI in the supply chain. So here, just a short recap of what is the supply chain and to align the vocabulary of everybody. So we like to present the supply chain operational reference model, which is presented in the slide. So here we can have a look on the different operations that are involved in the supply chain. So I'm talking about the ability to plan, which are the process that balance aggregate demand and supply to develop a course of action which best meets sourcing, production, and delivery requirements. I'm talking about also the source process. So those processes that procure goods and services to meet planned or actual demand. The make process, so these processes that transform product to a finished state to meet planned or actual demand. The deliver process, so those processes that provide finished goods and services to meet planned or actual demand, and typically including order management, transportation management, and distribution management. And one must not forget the last one, which is already the forgotten one. So the return process, very important. That's the process associated with returning or receiving return product for any reason, which extend into post-delivery customer support. So each process has its proper issues, like the lack of data, the data quality, the process interdependence, and many data sources are managed by several disconnected IT. That's the situation when the supply chain is not well managed. So companies use different models to try to connect the systems and have a new views on the issues. I'm talking here about rule-based model. We now have new opportunities in leveraging machine learning models, and I'll try to illustrate also what we call the artificial intelligence model. So let's start with what's a rule-based model. So in a rule-based model, the graphs here shows what we're looking for. We're looking for a new output. Here you have an input data, like coming from, example, the order management system. You have an algorithms that calculate the number of orders or maybe the delays or anything. And we want to optimize an output. We want to understand how many equipment will be shipped at a time. And here, the usually the data set volume is not a criteria, as many of these algorithms only puts a simple thresholds on the data, and we can here illustrate lots of different supply chain issues. On the right, you can see some challenges. So, for example, a classical route planner usually implements known algorithms. For example, the Dijkstra algorithms. It's an algorithm that shows you the shortest path between 2 points. We can also think of the example of a space optimizer, either for warehouse stock or for transportation. It's called the bounding box algorithms. And here in this case, we don't have a lot of data, but we want these data to fit in constraints. We also talk about constraints algorithms. And the last example is about the freight supplier recommender system. Because we want to satisfy some constraints, we have algorithms that can understand the variables such as the cost, the lead time, or the quality, or the carbon emission. And these constraints fits into an algorithms that finds the optimum, but without having lots and lots of data. We're not talking here usually of transactional data. We're talking about constraints, rules, and we want to find an algorithms that optimize a situation. The next kind of model is machine learning models. So here we're talking about, if I try to resume on the schema on the left, we have an input data. We also have an output data. That means the data are already labeled. I will come back to this. And we want to find an algorithms. So what's the purpose behind building an algorithms? Well, once we have an algorithms, we can reproduce a model. The model can reproduce phenomena and try to understand and predict what will be the next output with some input data. So in this case, we're usually talking about transactional data. And so they are usually with lots of them. The volume data here is important. And machine learning algorithms are mainly enabled to increase the speed, the accuracy of the model, and of course the ability of the results. So on the right, I can illustrate a few use cases of intelligent models that uses machine learning models. So for example, when we want to learn the most optimal stock coverage for each SKU, taking into account the seasonality and the security stock. Usually we can use threshold to calculate that, but when we have lots of data and external factors we want to monitor as well, well, it's better to have a machine learning algorithms that can learn the seasonality automatically. We can also think about how to learn the supplier's delivery lead time to evaluate the risk of the delay and eventually challenge the supplier's performance. So once again, we have lots of data here. We need to have lots and lots of transactions. And the last one is the ability to evaluate the risk of failure, for example, in the maintenance plan. We're talking here about predictive maintenance. And so it's important to understand that here data set needs to be in quality. It has to be labeled. The output needs to be known, and the objective is to build the algorithms. So now the third level of complexity in the implementation is when someone wants to automate an algorithms in the business process. And here we have a new paradigm, is that the decision is taken automatically by machine learning algorithms. And so it's much more risky. So as you see in the schema, the algorithms is known. We don't need to build it anymore. The model of prediction model, and we have a business process. And usually when we build a new machine learning, we also have to build a new business process. It's very important in particular to have a feedback loop in the process, so that a technician, an operator, or an engineer can control the performance of the machine learning model. And we obtain an intelligent robot. Actually, the process is automated with the algorithms, and then we have automated actions. So it's different from only a recommendation when we propose to a human the best next action. Here we think of a system that automates the action himself. And on the right, you can have some illustration of what is a real artificial intelligence use case in the supply chain. For example, we automate the schedule of maintenance interventions using asset failure prediction. This looks simple as it's said, but in fact is very complicated, as we know that sometimes the machine learning has false positives prediction. And the other example is about the fact that you can automate product order when you know that a supplier that you know that the customer demand increases. And here the demand sensing is also important to predict and to monitor as well. And so those are the three levels of sophistication in using data analytics for supply chain issues. So now, Igor,
Yes.
I think you are using data analytics in the SESAME project, which is a project about improving the supply chain. Can you tell us about the project SESAME?
Yes, I will present you the SESAME project. So this project is, so we will start with a short video in order to synthesize.
SESAME, or Smart European Space Access through Modern Exploitation of Data Science, aims to make Ariane 6 more competitive on the market using data science. When ArianeGroup builds a rocket, the subparts arrive at Les Mureaux to be assembled using FSW, or friction stir welding, a solid-state joining process that uses frictional heat generated by a rotating tool to weld two parts together. SESAME will allow to develop and use artificial intelligence on the welding machine so it can predict non-quality or incidents before they can occur. This will guarantee the quality of the operation without having to go through lengthy phases of control and maintenance. Once the tank is welded and integrated to the main stage, ArianeGroup then ships it to the Guyana Space Center, where SESAME will cross and analyze planning and geolocation data. Thanks to machine learning, algorithms will be able to increase the agility of our resources, thus maximizing their performance. No need to look for a specific tool or resource several kilometers away when another is available next to you. SESAME means improved quality and superior efficiency in order to better manage the cost of European launches while guaranteeing our self-sufficiency to access to space.
So yes, so this project SESAME has an objective to demonstrate the ability of European space company to work together in an artificial intelligence framework and environment in order to reduce the costs using data science for three main domains of our industry. The first is the predictive maintenance, the second is predictive quality, and the third one is supply chain agility. This project is a European project. It includes 8 European partners located in 4 countries and at a budget of 3.4 million euros. And as I said, is funded by the European Commission. In France, we have 4 partners, the CNES, Capgemini for IT services, Predict, a company specialized in predictive maintenance, and ArianeGroup as a project coordinator. In Spain, we have Eurecat, a company specialized in research. In Italy, we have Vitrosyset, a service company that works already with within the Guyana space port, and CRAT, a laboratory specialized in automation and data science from the University of Roma. In Romania, we have a public university called SNSPA, helping us on the ethics and in the human factors of the project. This project will be applied to 2 main use cases in order to demonstrate that we can apply the same framework for machine learning and data science within several use cases. And these 2 use cases are very different, the one from the other. The first use case is dedicated on manufacturing, especially the Ariane 6 tank manufacturing. And the objective is to predict the quality and the maintenance of the process. This process is called friction stir welding. You saw it in the video, and it's a quite innovative process of welding for tanks manufacturing. This use case is located in the Les Mureaux plant at ArianeGroup near Paris. For the second use case, which is located in Guyana spaceport, we will deal with supply chain resources and launch operations planning. And the aim is to optimize both the launch operation planning and reduce the supply chain and logistic resources that it uses in order to be more effective. This project is also about innovation in terms of information technologies, because we aim to create a sovereign European cloud platform dedicated to industrialize algorithms that help us to optimize our operations. And of course, we are dealing here with quite important data. So we will do it in a very high cybersecurity environment and apply best-in-class cybersecurity solutions for this. So the 2 use cases will use the same platform based on the cloud in order to help our partners that are located in several countries. So to work together and to collaborate into co-designing and co-developing algorithms to help our operations. So it's an enabler for a European collaboration in terms of data science. Our project is organized in 7 work packages. First one is about specification. What are the user needs on the shop floor and at the launch operations? The second one is more focused on IT management and IT innovation in order to develop and securize this cloud data platform. The work package 3 is about designing, more co-designing predictive algorithms. The work package 4 is how to integrate this algorithms into the operation and to have human-in-the-loop decision-making in order to improve all this process. Work package 5 is about precising, detailing how the use case, the two use cases benefited from the technology and how to be sure that it's correctly implemented. The work package 6 is very important because it's about communication and dissemination of the knowledge built by this project. As it is a European-funded project, we aim to disseminate the knowledge and the processes that we design in order to help other industries in their area of work to use the same kind of frameworks in order to optimize their own operations. And the work package 7 is about project management of in a 3-year period. We have a very lean organization with having set it to our 3 kind of operations that are involved in this project. So maintenance, quality, launch operations, and supply chain. We take into account by design the human factors. We have an information technology dedicated to data science and cloud platform. Of course, cybersecurity plays a very important role in this project. And as this data are from the space and launcher industry, we have an export control manager in the project. So we will speak about the second use case, which is more focused on supply chain agility in order to optimize launch operation planning, reduce the number of assets, and optimize the resource within the Guyana spaceport. We see a view of the Guyana spaceport here, and what the objective that we have on this spaceport is to better manage the production that is done there, so integration activities and launch operation preparation with the payload, with all the actors that are present in the spaceport in order to make the launch possible on time. And we aim to increase this resources agility when there is a sudden change in operation or an area that occurs. And in order to reduce our cycle times and thus the cost of this operation, we want to better identify a bottleneck in these operations. And last but not least, ensure that our products are safe, especially as we manage some chemicals and dangerous products on site. We can benefits in this project from the Internet of Things technology. So the IoT trackers will help. This technology will help us to collect more and more data about where are our products, what are they, in which operation they are, and better manage them. So we expect to implement IoT technologies on several logistics means like handling material, forklifts, trucks and trailers, but also industrial tools. And we will collect data that will help in our decision making, like the location from GPS, the pressure and aerometry, the temperature for some projects that need temperature control management, and we will timestamp all the operations, that's the steps in the operation using this technology. And as this technology of IoT is available on all along the supply chain, we will be able to collect data on the road, during transportation, into warehouse, inside building, inside factories, inside the final assembly line of the launchers, but also at port, during transportation, during logistics operation, and even on the transatlantic transportation boat. All this data will have a big benefit for end user by giving us two kinds of applications. The first one is quite common. It's a geolocation application. It will help to either to find and receive parts in containers, to locate them, to locate tools, but also to give them alerts and SMS messages using geofencing in order to see if some products have left zone or are about to arrive, or if they are expecting a delay. And we expect also all these measures to help them to secure lead times by doing more data-driven value stream mappings. And of course, it will give them reports and dashboards on utilization rate, last maintenance dates, shelf life, things like that. In order to get next level of intelligence based on this data that we collect, we expect to build predictive applications dedicated, for example, for planning, forecast for logistical sources, predict local demand, predict estimated time of arrival for containers in order for logistics operation to anticipate receiving, unloading, handling operation, and have the right number of people ready when another gauge container arrives. But also to identify deviation in the logistic process, for example, bottlenecks, but also delays in the process. There is a kind of illustration of what's already in place in our operation. So we see an IoT tracker that we install on containers, and two screenshots of the application. The one is monitoring the monitoring map, where you can see and drill down into the data location by location. And the second one, which is more for analytics, that gives an overview of the utilization of the product, all the movements, last movement during a period of time. And it will help to supervise the supply chain flow, to reduce also the work in progress, ensure product safety when you have alerts about a product that had a deviation on its routing, and also optimizing container fleet when it's containers that are reused and that are sent to the Guyana Space Center and that come back to Europe, and also measure end-to-end lead time to improve our processes. In order to go a bit deeper in how we will do that, I wanted to show you a kind of data flow for dedicated to logistic resource prediction. This data flow uses two kinds of data, some quantitative data and some qualitative data. The quantitative data comes from our ERPs and historical data series coming for our logistics information. So second data comes from IoT trackers. It gives us a location or position of the container or the tracking device. And the third kind of data is a profile of the customer. It's the internal customer. Is it manufacturing, assembly, integration, or test? And what are his priorities compared to the others? We will use, for example, in this data, first by cleaning, filtering it, enriching it, combining it, and then to develop a predictive model based on this enriched data, and then provide some insights for planning the logistic activities. For example, if we want to increase the service level in time of critical operations, we will be able to optimize the performance ratio between service level for the internal customer and logistic resources that are planned to work on these operations. So that's a kind of algorithms of data flow that we will use in the SESAME project on the second use case.
Well, thank you very much, Igor. That project looks very, very interesting. So, can you maybe particularly precise what Ariane is looking for in developing this, and why Ariane is developing in this kind of project?
In fact, our supply chain is not, and our operations at the supply chain department, we are not all that, we are not data scientists, and we are more into the business. So we have no, we have a need of developing with and collaborating with specialists like data scientists, like IT people, and in order to get the benefits and the value added from all this data, in order to be able to optimize our operation. The second reason why we go into this kind of project is that the supply chain use more and more data from the internal side of the company, but also from the external side. For example, we have data from our ERP, enterprise resource planning, our manufacturing execution system, our transport management system, but also new kind of data like the IoT data. And we need to leverage this kind of technologies and data. We really need the participation of several partners to help us with making value from this data. It's not so simple. The third reason is also to be able to use this data to have a direct interaction into the operators. For example, when the manufacturing operator has a need of a forklift truck from the logistics, and the logistics is using several forklift trucks on a big and a large site, he needs to be able to identify very quickly this logistic mean, and using data, geolocation, and also other technical data characteristics like fork length, maximum load that the forklift truck can use, will be needed. And in order to have all this information combined together and use it in an efficient way, we need other technologies and people and partners to make value of it. We have many use cases for optimizing our supply chain, but we need to develop it collaboratively and involve support functions, engineering, IT, and data scientist specialists.
All right, very good. So if I try to resume your main reason is you're looking for new skills and data scientist skills. You're looking for leveraging all the data patrimony you have and also new sources of data. You're looking for the ability to interact with real business operation issues, and you looking for collaboration because as everyone know, the supply chain is really an end-to-end process, quite complex, and everyone needs to be aware of the issues of each other. So we have lots of technological solution and interesting features to propose for this. And as you say, business challenges are numerous. So At PwC, when we talk about business challenges, we like to oh well, I will talk about that a little bit later, actually. So I would just like to illustrate relevant tools we built in some of our experience. I'm talking, for example, of ramp-up context and the ability to forecast accurately at a short term and at a long term the demand of a product. This is a crucial information that our client asks us a lot. And we've been asked also for ability to define the security levels of commodities in warehouses, as it is very important for safety reasons, and in particular in the energy and utility business. So all of this implies lots and lots of data. We talk about the seasonality of the demand and etc. So at ArianeGroup, can you maybe tell us a bit about the use cases you intend to address?
Yes, at ArianeGroup, we interviewed the operation and we work with the operation. We see arising a lot of use case, but one that mainly is more often as a feedback. We need some tracking capabilities, and in order to improve the visibility on our containers, our equipments, both for logistics operators and also for manufacturing and integration assembly operators that need this specific part of this specific equipment for the next operations. So improving the visibility using asset tracking that use IoT technology is a very important use case. But also, there is not only tracking, there is also lifetime improvement. We want to be sure that our products are maintained correctly. We want to save time in the localization. We want to be able to better manage our assets, avoiding redundancy and optimizing the fleet. For example, the fleet of containers that travel between Europe and Kourou in Guyana. Also, we want to be able to understanding trends, for example, detecting delays when a specific process has a tendency to be delayed. We want to do root cause analysis, and also being able to handle anomalies when routing has not been followed, when a product has been delayed. We want to understand that. So, predict the process deviation can be very interesting in order to mitigate the risk and having less and less issues. Also, of course, we need our operations to have a better supervision of their work. And at ArianeGroup, we need to reduce also the time that spent into fastidious operation of control in order to improve and improve the whole cycle time. And last but not least, as we manage a lot of dangerous products, we need these products to be safe for the environment, safe for the people, and we need to make sure we apply the right regulation in order, for example, not to mix some products together. So for this is also a use case that is aimed when we do this kind of projects. That's it.
Wow. So we can see many challenges. So I was talking about, sorry, I was talking a little bit about it earlier. It's important not only to brainstorm on all the use cases, the potential use cases, but also to try to illustrate the added value for the business and There are methods for that. For example, at PwC, we use first lightweight canvas to structure the development of use cases, and then we try to illustrate the benefits of the use cases, and we select them the best use cases, and we go further in the definition of it. We usually describe the benefits of the use cases along 4 axes. Um, the first one is addressing the top line. Does this use case help to sell more product? The second axis is the bottom line. Can we avoid costs using developing that use cases? Can we improve the efficiency of our business, and in particular of our supply chain? And of course, can we mitigate some risks? You talked about it a little bit, Igor, when you handle dangerous product, and it's very important to highlight these in the use case. So can you maybe illustrate the business value you maybe already had in the development of your use case, or the risk you mitigate?
Yes, of course. Alors, one axis that you talk about, which, for example, the bottom line improvement, can be illustrated by our use case of visibility for operators of the fleet of forklifts used on a big site. We have a very large site in France, and this industrial site has had a large fleet of forklift trucks that were used by the operation. And when we used trackers on it in order to collect what was the real usage of this forklift, we were able to work out with the operations people that we could reduce by 20% the number of forklift trucks in this particular site. So it had a really big impact on the cost of logistics on this site. The second axe that can get a benefit from this kind of project or technology is, of course, risk mitigation, because, for example, we have a chemical product that is transported by a tank on trucks, and this particular product needs to follow a routing from our supplier to our processing plant. And using this IoT technology and some geofencing mapping, we were able to be sure that the product has followed the right routing. Another example is for temperature-controlled chemicals and products like composite materials. When we need to monitor the temperature on our raw material supply, and in order to be sure that the shelf life is safeguarded. So using these small trackers that were able to measure temperature, we were able to see that our product was safely transported, maintaining the appropriate temperature. So this mitigates the risk of having a product with a short shelf life at destination, or a product that has been modified due to temperature due to inappropriate temperature control. So this three use case illustrates the real business value that we had in this project.
All right, very good. So it's important, yes, and I see you are looking to address the lots of business value, especially on the risk and the efficiency, and of course the bottom line, where you were able to save 20% of your forklift trucks, which is quite impressive. So now we want to talk about artificial intelligence, and where is the intelligence in the all of this. I introduced by trying to present 3 levels of intelligence. Can you illustrate what is for you the first level of intelligence in what you've been doing within your projects?
Yes, in fact, the first level of intelligence that we can use based on the data that we were able to collect is, for example, the definition of a geozone. Before we had only contracts, we had only our eyes to view it. Now we have data, we have geolocation, and we can easily define zone, make alerts, sort the data, and this is the first, I think, level of added intelligence to the system and to the data. I think the second level of intelligence is when we can automate some alerts. It means that we are able to label the data and create new business rules, new smart rules that help to build alert in an event of a delay or an area. This is is helping the operations people to be more aware about what is happening, even if they are not directly on site in the operation. So that's, I think, the second level. For the third level of intelligence, it's more difficult, but maybe we can speak about it after.
Yes, okay. So I understand you have the first level of intelligence is being able to label the data. This is, of course, the first step for any artificial intelligence project. We need to, because labeling the data is often complex, and with IoT Tracker and defining geozones, you were able to label quickly your data, and that's very good. So when one starts to automate some business process, thanks to data analytics, it is very important to build a robust governance and an ethical framework to secure that employees trust the system. I know we have questions about that. And it's important at PwC, we usually take an important step explaining and demonstrating the ability of the system. And what's convinced a lot our client is the demonstration on the root cause analysis, for example, of a failure, of a delay, of anything. Once we've illustrated a root cause thanks to data analytics algorithms, people trust the system, and then they are aware of why it's important to have clean data and what will be the benefit for them. So maybe can you illustrate, Igor, some data analysis use case you deployed at Ariane? I know now you have lots of data.
Yes, for an example is managing the reverse logistic process. In our industry, we have some industrial process that necessitate to have a product or subcomponent going to supplier and coming for the supplier to us, but also coming back from repair operations back to our industry. In these processes, usually people faced communication issue because the ERP we use and the system our supplier or repair agent use are different, so they don't communicate well, and so it makes all the process very choppy and very siloed. And using more analytics and connecting our supply chain better with our suppliers and our repair agents can help to people to demonstrate that these communication issues that we had previously are now resolved by having more analytics. And when in addition you can add a capability of geolocation, and you know exactly where the product you had sent to a supplier and know where it is exactly in the warehouse, in inspection, still on the dock of repair. It's very time efficient, and for the user, it's a way to embark better the operation people into this kind of projects. So we try to build this project with the operations directly at the beginning.
Yeah, so you can have a big impact on important KPIs for the supply chain, and also explaining phenomena. When we prepared this webinar, we talked about also some phenomena you wanted to understand. So, for example, a container that stays too long on the ports or on harbor, on harbors. Why is the ship not leaving the harbors? And actually, if you combine external data such as weather data or the degree of fill of the container, this can explain reasonably why containers has stayed too long at the same place, and so for that you use small algorithms that combine the data. Now, if we want to illustrate machine learning algorithms, it's those are particularly used and developed when you have lots and lots of external parameters. So we talk about the weather, we can talk about the traffic, we can talk about any external conditions, and for example, crisis, of course, such as the one we're living currently with the COVID. And all this data and the levels of awareness of the traffic routes or whatever can influence the performance of routing, of a delay, of a lead time, of lots of things. So we were talking about a third level of intelligence when we want to try to automate the decision that machine learning algorithms can recommend. It's very difficult yet to have concrete use cases right now in the supply chain. Of course, everyone is talking about autonomous vehicles. And this is the most brilliant use case that we can see. And of course, we got lots of autonomous driving engine now in warehouses. Maybe if we think about other use cases of that can be automated, we were talking about, Igor, on the ability to automate the command on the shipping of objects.
Yes. Yeah.
And we also, I know we have questions. I'm sorry, we're a bit late. I know we have questions about it, about the ability to track the carbon emission of a supply chain. This is really a critical issue for sustainability. And can you illustrate what you're trying to do with this?
What we would like to do in the future is in order to reduce our carbon footprints of our whole supply chain, which is quite large, with lots of transportation means utilized. We aim to collect and combine data from different systems from our supply chain. First, our ERP, so enterprise resource planning data, our transport management system data, our geolocation system, and also our purchase ordering system, in order that we can be able to automatically propose grouping and consolidation of cargo from our supplier base, and reduce by this the number of dedicated transport and maximize the fulfillment of our shuttle trucks with several cargo from several suppliers. And it's if we take the action locally, supplier by supplier, we have the risk to have many transport ordered, and so a big carbon footprint at the end. But if we have an intelligent recommendation system that can help us to decide to delay, for example, a big component because some sub components or hardware is available and can be shipped together in the same shuttle without delaying the whole Ariane supply chain. That will be a really intelligent system, and that collaboratively help the whole supply chain to reduce its carbon footprints. And this would have also the advantage to reduce, of course, our stock and work progress at destination sites, our final assembly line, save cost on transportation by delaying some dedicated transport and grouping them into shuttles, save cash, and of course at the end have a lower carbon footprint for the whole group without delaying our transportation. So that's really the vision that we could have for an intelligent transport management system.
Thank you very much, Igor and Marc. I suggest now that we take questions from the audience. I must admit this webinar got a lot of questions, so I will start right now to ask you a few of them. I hope we can address most of them. We negotiated with BrightTalk to have an extension of the webinar. Okay, so let's start. It's about the SESAME project. So that's for Igor, how do you measure the supply chain agility for the SESAME project, which you mentioned at the beginning of your presentation?
Very good questions. Okay, so how do we measure supply chain agility? In fact, supply chain agility, I think, is all about having a ratio of delivering the best service level. It means having an on-time in full delivery of all our components to our final assembly line with the minimum resources used into that. So if our supply chain is agile, it means that we can move this ratio and optimize whether our service level or our resources. So this is one of the main agility KPI I will get. The second one is to be able to replenish and have a new scenario of planning very quickly in order to respond to an area of production or an area of delivery or a delay in some components that arise. And so being able to, we will be agile if we can replenish and propose different scenario of planning very quickly in a few days. I think it will be a great show of agility for our supply chain.
Okay, very clear. Again, that's about your presentation and the work package slide when you showed the different work packages. So how do you plan to disseminate the knowledge that was part of work package 6?
Yes, we plan to attend several conferences. So now it will be online conferences, but also our website will be soon, public website will be soon online in order to publish all the material that are aimed to be public for this project. Then we are, of course, open to question and benchmark for companies that want to discuss with us. And we'll be able to be in contact directly. That's one of the key points. And also there will be a European Commission actors, which is called Cordis, that collect all the work, all the knowledge, and that publish it and make it available for other industries, SMEs, startups, and also the research and academics.
Okay, so it's cool. We are part of this work package 6 then today.
Yes, we are. Yeah, more communication. Yes.
We see other questions, maybe more technical. Or did you see any challenges around the data collection to set up your software application? Basically, data equal DSS, small advertisement.
Yes, so the data collection is I don't think the data collection is the main issue. We have usually a good amount of data, but it's having the right data. In fact, sometimes we have a warehouse management system or a module of our ERP that have a lot of data, but this data is not always in the good format or collected with a high enough frequency to be used and to be used to make an algorithm learn from it, or to make a data scientist use it to make a prediction, because the format is not right, because we cannot merge it with another data. So it's not too much about collecting, it's just having the right data. So it happened that we had to deploy a new application just to collect the right data that we were using in our prediction.
Okay. Other question around, so, okay, I'm going to read the whole stuff. So, hello, great project. So thank you. How much time did you need to implement it?
The SESAME project started 1 year ago, but our IoT project started a little earlier. So our main issue was how to be sure that we were deploying our project with the right level of security, and I mean cyber security. So this was the main challenge to cope with, and I think that's why it takes a bit long to be deployed.
Okay. The next one is around security. So how is ArianeGroup managing security constraints regarding data management in a project that is relying on the fact that all stakeholders need to access those data, and those stakeholders may be internal as well as external?
So that's one of the biggest challenge of the project, is to be able to share data and the right data with our partners. So how did we manage it? First, we are collaborating since the beginning with our cybersecurity department and our IT information technology department. So these two functions of the company are involved since the beginning in the project, in order to have security, I mean by design, with an infrastructure, an architecture, an IT architecture that cope with the challenge and the risk of security. So we started with good risk analysis, and then we had our expert from both cyber and IT involved in the project right at the beginning. For I think that is the best way to cope with it.
Okay. Again, a question for you, Igor, and I think it's a good one that is beneficial for every activity, not only supply chain. But okay, so do you think it's possible to use only AI for solving the complex problem of supply chain, especially when we have to find a financial compromise solution or trade-off between several costs and profits? You see where it leads. If not, which kind of approach could be complementary to AI? I talked about presentation prescription part of data analytics and not about prediction activities?
Okay, so if I understood well, the question is so I think that, of course, there is not only AI to do that, and that human is always underrated, and that having first good processes that are streamlined and well organized and goes along well with what people at the business, at the operation are doing is the first step that will always give good results first. And then on top of that, on top of this good process, of this well-engineered, well applied and well described clear process, we can collect data to measure this process and to then see if they are efficient and adapted to the operation. And the third layer is to have artificial intelligence or machine learning exploiting this data. But I definitely think good processes and good and well-trained people make the first foundation of a good and efficient supply chain, and also a cost-efficient supply chain.
And we are reaching. Okay, no, still questions are coming. Okay, so I'm going to maybe to simplify the next one. So, is there a plan to make the SESAME project available as a kind of solution to the European community or the European space, as a European space collaboration solution?
Yes, yes. So this project is it's today a research project. So I like to say it's an applied research program for operations. So we are testing things, we are experimenting, but our aim is to deploy a solution that is reusable by other industry, and I hope in the space industry, but not only. I hope that other manufacturing industries in Europe can beneficiate well from what has been developed, the frameworks, the processes, the IT solutions, the cyber security solution for this IT, and all these collaborative tools and platforms on the cloud will be used by others. So it can be a service that is used by others company after the projects, the SESAME project. Yes.
Okay. And we are going now to the last question, but it also touches some points that we already addressed a little bit. So traditionally, we use operations research-based models to improve the performance of the supply chain. So how do you combine operations research and data science AI tools in your project?
Maybe this is a question also for Marc, because I remind that he's in his white paper was some.
I can take this one. Yeah. Thank you, Igor. You're right. Operational research algorithms usually uses small data or quality data. They are solving constraints, and the objective is to minimize the cost function based on few data. I'm talking about, for example, of space optimization or route optimization or those kind of things. So that gives usually a baseline. Once you have transactional data, you have history and time series, you can try to implement data science algorithms. And if you go with the performance of prediction or recommendation that can lead you to something above that baseline, then you won. So I usually recommend to try simple models like the one based on operational research. And once we have that baseline that measure performance, we can try to gather more data and history data and try to model all this in complex machine learning algorithms to improve that baseline and improve the performance of the business.
Thank you very much, Marc. So I'm wrapping up. We are now at the end. It was really amazing. So thank you all for your attention, and of course thank you Igor, and thank you Marc for presenting us your updated vision of the issues related to the supply chain, and also for giving us insight to move from reflection to execution. So if you wish to deepen the subject, we will make available our joint supply chain white paper with PwC, and you will also be able to replay the video. So again, thank you all. Thank you, Marc. Thank you, Igor. Have a nice day.
Thank you, Ron.
Thank you.
See you.
Nice day.
Bye-bye.
Bye.